Okay, so welcome everyone to Guided Study Group week 1 of Stat 100. So my name is Han and this is like the first time doing Stat 100. Usually I'm going to be taking care of Math 140 and 141, so Calculus 1 and 2. I also do tutoring for Stat 200. So Stat 100, in my opinion, is more conceptual and less calculations compared to Stat 100. And so if you're not good with numbers, as I said in the email, don't worry too much. As long as you understand the concept and maybe like reach out to me or Ellie or Scott anytime you have any questions. I think you should be doing a pretty good job in this class. So far, what I have today is just a quick review of lesson 2 and also some practice problems. But before that, we should go over some of the kind of like housework first. First thing is the guided study group review sections, just like this one, is going to be every Thursday at 10 p.m. I apologize for making that mistake in the thing because I was actually thought it was not 8 p.m. It was actually 8 p.m. until this morning, but I'm going to change it after we finish. At the start of every sessions, if you join in with me online, please enter your PSU ID into the chat room as like an automatically thing so that I can keep track of the attendance. And then every sessions, as I said, we're going to have a quick review of the week lessons. So I usually base a lot of my notes on the online notes and also your assignment questions, and also like as I read through it, because this is also my first time taking Stat 100, but I'm sure we're all gonna get through this class together. So we can do it. Then we also have some practice problems that I'll base it on the assignments and also the practice problems online. But if you do it, doesn't mean the fact that you're going to be able to solve the homework or the assignment. It's just kind of like a reference point to see what you need to understand in this lesson. And if you don't understand something, and like don't know how to do the questions, you know the fact that you should reach out to us for question and all of that. And also at the end, I'll be open for any Q&A if any one of you online have some like questions to me. Finally, we have the midterm week. So the midterm week is going to be, I'll do the review sessions at 9 p.m. every Sunday before the midterm week. So those days, as I was told, is going to be fall on June the 10th and July 15th. So that's everything I have for just like housework and some of the rules that we have to go through. Just like a quick introduction about me. My name is Han. I'm currently at the second semester of my third year in chemical engineering, and I also do minor in industrial engineering. So industrial engineering is kind of like the reason that I have to take stat class. I usually do with stat for 14, for 15, and before dealing with like 200 and 100. So it's kind of like a different track for me to tell you guys that I kind of like know most of the thing before I get to stat 100 and 200. But again, this is my first time, so we're going to survive the class together. Anyway, back to the lesson is, so today we're going to have statistic, risk, and measurement. So it's lesson 2. So I would say just like one of the side notes, along with your class note online on Canvas, I think the notes in the new online courses, I don't know if you guys have the link yet, but it's called give me a second, I'll put it up. It's the new online courses, science.psu.edu stat 100. So I think that's a very brief note, and it's very helpful if you kind of like struggle with the reading assignments and see like, okay, what's the point of reading this? Or like, I want to see the main points and see what directions of what I should looking for in this reading assignments every week. That is the place to go. So this week, we basically kind of like familiarize ourselves with the very basic concepts in Stat 100. So the first thing we're going to go through is what is experimental and observational studies. So experimental and observational study are kind of like the two main types of like two main methods that we use to study statistics, how to like obtain data. So the difference between them, as I clearly show on the slide, is here is experimental we use a lot of manipulations, kind of like we do some interventions on whatever we want to test. So say if we want to test two groups of people and see how good they are with reading, compare like one is we let them use computers and one we let them read like normally. So that's one of the experimental studies. On the other hand, observationals is where you usually just make observations based on the natural living of that subject. So it doesn't have any interventions from us, or we don't divide them into groups. We just basically making observations on how their life is and how does it related to what we want to test. In experimental, we also have, as I said, researcher was gonna impose a treatment, and usually they're gonna randomly assign participants to groups, and so that's when we have the randomized experiment. So that's a very important thing that differentiate experimental studies and observational study, because observational study will not allow to make interventions and we just basically make observations. The groups is there, like the groups, the way that we divide the groups is already there. We cannot make any randomization and make sure that it's, cannot like just randomly put them into a group because the characteristic already belong to that subject. So usually not randomly assign participants in group. And then so because of that, experimental study usually have a better control on the variable or like the subject that we try to test. So like the characteristic is usually used for scientific study where you want to learn like the effect of just one thing on the subjects. On the other hand, observational study is kind of like more limited and it's only allow you to draw the associations between two things. So say if you have more, if someone raised a cat or a dog and they turns out they usually are more happy, then you can only relate that okay, there's some association between raising a pet and be more happy, but it doesn't tell you okay, raising the pet is the reason that that person become happy. That's not the case that you can draw. That's not like one of the conclusions that you can draw from observational studies. On the other hand, experimental study, because of the randomization and the better control that I said, it allows us to draw, in certain cases, it allows us to draw the conclusion of a cause and effects relation between the two subjects. So that's the main difference and how you differentiate between experimental and observational studies. Then some of the things we need to know is the questions in statistical research. So there are some things when we kind of like ask the research questions, there's something that we usually run into that we're not quite aware of. Usually it's just in the way that we phrase the questions or kind of like the way that we ask the questions. So some of the problems that we might run into is deliberate bias. So it's more like when you're asking a person, say, do you agree with something? Do you agree that we all gonna pass this class, or do you disagree that we're gonna pass this class or something like that? Then it's usually occur when someone asks you like a one-sided questions. They don't ask you something like, do you agree or disagree that we're gonna pass this class? And usually that's not the way that we use in, say, casual conversation or daily life talks. But in statistical research, the way that we phrase it is to you have to usually do like, do you agree or disagree with something, because that's the way that we're gonna avoid deliberate bias. So it's usually in the way of asking one-sided questions or in the question phrasing. The other one is filtering. So filtering is when we have, say, you give them just limited choices of the answers. So say if they ask you, okay, do you agree? Oh no, like what is, say maybe like what's your opinion of the current president? I will take the example from the notes then, and then they give you two answer choices: is favorable, B unfavorable, or C undecided. So in some cases, they're just gonna ask you, okay, A, favorable, or B, unfavorable. So it depends on the choices, and that's just kind of like limiting the answer choices that you can put in. So that's what we call filtering. So in statistical study and research, usually we try to make it open-ended, or kind of like, even if it's open-ended, we try to make it like in the way that we can include as many answers that we can. And then the next one is importance of order. So importance of order is when a person usually asks you just like pick a color, red or blue. Or they can ask you another way, pick a color, blue or red. I mean, usually we're gonna think, okay, this is just, when we actually have some time and think about it, and then you're gonna be like, this is just the same questions. It's just not two different way to ask it. But actually, you're gonna be amazed of how different is the result when you ask them pick a color, red or blue. The answer actually favor more red. And then on the other hand, if you're asking pick a color, blue or red, the answer turns out to pick more blue. I mean, with the same questions, there are two different ways that we ask it, and that's the reason. Just like one of the problem that we end up having in, kind of like, statistical study, and those are the kind of like when we ask someone a questions in our study. Usually, these are the things that we're gonna try to avoid. Next one is anchoring. So, this is where you have, say, they give you some phrases before the questions and they ask you that, and it kind of like give you a false illusion of what we should expect. So say usually they're gonna ask you, say, Everest is what, 10,000 kilometers height. What is the height of the second peak of the mountain? Or like the second height, what is the height of the second highest mountain? And usually you're gonna have an impression, okay, if it's 10,000 kilometers, usually you're gonna think like the second one should be around like 7,000, 8,000. But if they ask you another way with the same questions, so given that the height of the third highest mountain is 4,000 kilometers, what is the height of the second highest mountain? And usually your answer now is going to be 5 or 6,000. So actually it's the same questions, but we get the illusion from the first phrase in that questions, and that is one of the problem that some people might run into unintentionally in statistical study. So that's some of the things that we might want to take a note of. The next one is unintentional bias. So these are the way, these are not the one-sided questions that I mentioned before, but there's gonna be sometimes just the way that you use the word. It's not like, do you agree? Usually they're gonna ask you, do you agree or disagree of something? But the way that they phrase the something part is the problem. So usually they're gonna ask, say, do you agree or disagree that we cannot party all night? So research show the fact that people tend to answer no to these questions, even though they might not think about that way. It's just study shows that it's just a person just like a human nature is that they tend to answer no to something when they're being told that they cannot do something. And usually if you ask them the same questions but you phrase it the other way, say, do you agree or disagree that we don't go party all night, then people is gonna be like, the percentage of people answering yes is gonna be higher than the way that we asked before. So that is where we have the unintentional bias, and this is coming from usually if people were told that they cannot do something, they're gonna usually answer no to it. The last one is the unnecessary complexity. This is where you'll be asked things like questions gonna be asking us about something that we have absolutely no idea of. So say, do you think that healthcare workers and military personnel should be the first to receive the smallpox vaccination? In the way that people think it's a very long questions, and it has a lot of information. So you have to think about what is healthcare workers, what is military personnel, and also smallpox vaccination, and what is the kind of like the information related to healthcare workers and military personnel. What factors are going to decide who's going to receive the vaccination first. So it makes the question unnecessarily complex. If they phrase it another way, say who should have priority to receive the vaccination? A, healthcare workers, B, military personnel, C, both of them, or D, neither of them. Then it's gonna be easier when you can like cut down the information in chunks so that people can digest it better. Another one for unnecessary complexity is where they have double negative. So usually they're gonna ask you, don't you agree that we cannot go party? I'm just like, okay, you have don't you agree? And then you have we cannot go party. It's just like make the questions when you twist it twice and you make it much harder for the person to understand. Why don't you just ask them, do you agree or disagree that we can go party all night? So that makes things much easier than you twisted the first one and you twisted another way. So it makes things much harder to just like process it. So that's some of the things that we might run into in statistical research, and usually when people try to ask these questions. So it's depending on the ways that we phrase it, and also just like try not to twist it so many times, then it's gonna make the research purpose much clearer and easier for us to like evaluate the data that we have. Then we also go through the concept of variables. So variables is kind of like the core of statistic in the case that when we try to obtain some data, variable is the one that we want to focus about. It's the reason that we want to obtain data. So usually it's something that we can measure or take on different values. Usually it's taken by observations, or you ask them questions, or if you do like experimental study, you get them to do to be in different groups and you put them into different methods, and the result and the data you obtain is just based on the observation of maybe like that subject's performance or like how they behave during that process, those stuff. There are two main kinds of variables, which is categorical and measurement. So categorical is where you have the characteristic or the variables that you're testing is label or grouping. So say we have like name of cars like Mercedes or BMW or Chevrolet or something. I don't know how to like actually pronounce it honestly, because I'm not really a fan of cars. But anyway, it's just the name or the branding of the group that you put them, say like high grand cereal or like low grand cereal, kind of like that. Then we have in categorical, we have two smaller subcategory, which is nominal and ordinal. So nominal is the one that it doesn't have like the order. It's just the name of the group. No one can say like BMW is better than Mercedes or Everest is better than Ford or anything like that. So it doesn't have any order. But ordinal is the categorical variable that have an order. So say, let me think of it as kind of like a hard one. So say if you have like high quality cars and low quality cars, so that actually mean an order. So it again depending on how they phrase your variable and the way that they put it in words, that we can actually put them in if it's a nominal or ordinal variables. Then we have measurement. So measurement is where usually your data is gonna come in numbers. So we have discrete variables and continuous. So discrete is usually things like I'm gonna say how many airbags that you have in a car. So say 2 or 3 or 4. You cannot have like 4.5 or 4.2 airbags. So that's where we have discrete, where they cannot go continuously. So say like 2 and then 2.1, 2.2 go to very, very small variable that it span continuously. On the other hand, if they're asking you how many liters of gasoline does the engine converts, then it's a continuous one because it's a volume. You cannot specify that okay, it can only run 1 liter or 2 liters of gasoline. It's a volume and it's like a continuous thing. It doesn't come in chunks. Like you don't have like you don't burn just like small chunks of gasoline. The flow of gasoline is continuous. just a way to think about it as like a chemical engineering student is that when you think about process plant and you have a lot of flow coming into the plant like materials, and those of them are usually just continuous because they flow and get supplied continuously into the plant, if that helps think about this thing. And then last thing of variables is where we try to looking at the test of the like the data that we have, and we have to care about the problem of bias and reliability. So say if you have like you have your samples and you just measure their, say like you try to determine someone's heartbeats and you take say 10 seconds, and then you have a bunch of data of the number of heartbeats in 10 seconds, and then you start multiplying it by 6 to see like how fast that the heartbeat in a minute. Then that one, if you compare it to the data of 60 seconds, if they match, you can say that it's unbiased, but at the same time, you make it unreliable. This is because of the fact that you assume that you just take 10 seconds and it can represent 60 seconds. That is where usually we have the unreliable method. On the other hand, you can have a bias but reliable method. So say like, let me think about one thing. So say if you know the fact that this population is, if you want to take a sample in a location and you want to represent it as like the characteristic of the entire American populations, but you know that area is like representative already, then when you just take the data at that location, the study is biased because you choose it. You choose the samples that you're gonna take. But if you know, if you have some evidence that is representative of the population, it's a reliable, it's kind of like a reliable samples to take. So I mean, if you look at I would say the way that we look at it online is a bit, it's kind of like hard to say it like just conceptually like this. But I would say if you try to look at maybe the book, or I wouldn't say tell you to try the assignment because they're gonna affects your grade, but working on the exercise and see like looking at how they phrase it and looking at the example, and especially I think the notes online, because I think it has a lot of example, especially at the ending like 2.5 or whatever it's, yeah, 2.5, where you have a lot of real life examples. I think it's going to be a very helpful way to get you understand the concept. Then finally, the last point we have today is samples and populations. I kind of like go ahead of these two a lot before we actually come to discuss them. So the populations, difference between samples and populations is that very easy when you just think about like American elections and you try to take the data from the populations. Obviously, you cannot give a data sheet or like a survey to every single American citizen to take that number, because they're going to be just very time consuming, and it's very hard to make sure the fact that they're going to answer, everyone's going to answer the survey. So what happened is that usually we want to make a conclusion about the big populations based on the data we get from the samples. And the sample can just be like, you take that survey to like a state, or you send them randomly to say 100,000 people and try to get like draw some conclusion from their answers that sent back to you. So populations is like a very big group, and usually that characteristic is going to be fixed. It is because we're talking about like, you know, a biggest set of data that we can have. So it is very inclusive. It has all the information we need. So usually that characteristic is fixed because it already includes everything. It doesn't have the tendency to change anything anymore. So that's why we define it as like the biggest group of data that we can have. On the other hand, samples might be representative of the population or not. So the characteristic of this sample compared to the other sample might be different. That's why we say that it have a tendency to change. And usually that's where data collections comes from in reality. So I mean, if you guys doing business, you can see the fact that if you take data from, you try to get, say, like, what's your customer preference, how do you maximize your profit, how do you figure out how much to sell and what price should you put on it. These are, you're gonna collect data from your customers, or you're gonna get the data from a market company. So it's kind of like we're trying to get that data. It's a small amount of data. There's no way that they can get all of the data from every single person that you want to target the population. So say if you want to target world populations, there's no way that they can get the data for all of them. So that's where you're going to get the data. And usually, if it's reliable or not, that's why we're trying to think about, okay, if a sample is representative of the populations, because if it's not, we cannot use it to draw inference about the populations. So that's also come from a lot of the things that we're going to discuss after this lesson, like how to come up with a research study, and what are the things that we have to pay attention about to make sure that our data is reliable and unbiased. And then we have, so yeah, that's coming from the desire to represent the populations, and usually, but not necessarily. So say, as I said before, say I get the example, if you know that that state have the representative American populations, you don't need to take a lot of data. You just need to take the data from that area because it's representative already. However, in reality, it's really hard to make sure that, okay, you know the place and that sample is going to be representative. So usually it comes from the sufficiently large sample, but it's not like a required conditions when you do research study. As long as you make sure that the representativeness is guaranteed, then that sample is reliable. So that's everything I have for concept. I guess you guys must have like understand at least 60% of what I'm saying already, because you should have looked at the lectures and, you know, get the general idea in your head. It just needs some consolidation before we actually come to do assignment. So let's start it with question. If you look watching it online, feel free to like pause me and work on it until you are like comfortable to answer it before, instead of just like jumping into the answers that I'm going to give out after this, just to get your mind to practice. And I think it's a very helpful way to study, not just in statistics but also in calculus. That's exactly what I did make my students online do when they do their exam review with me, or just like weekly review. That actually boosts their, I don't want to brag about it, but it actually boosts their percentage for like performance in class for at least 20%. So that's going to be the main approach. So the first question is going to be, consider research questions. Do you agree that planned planning should include exactly one emergency response plan? Which of the following pitfalls associate with the questions? A is ordering of questions, B, unintentional bias, C, unnecessary complexity, or one-sided questions. And just don't look at the last part yet, like just don't look at this part yet, but I'll give you guys, say, like 2 minutes to think about the questions. Don't look at the bottom part. And then we're going to be back after that. Okay. Okay, let's get to answer these questions. So the first part is consider so the answer to this question is a one-sided questions very clearly in the way that they phrase the question. The first thing that you read about is, do you agree? I mean, if you have been listening to me since the beginning and also look at the example, the way that they phrase research study questions is make sure that people don't just have one, they try to include as many answer choices as possible. And so usually the way that they ask is, and the correct way to be like the most objective that we can be is, do you agree or disagree that planned planning should include exactly one emergency response plan? So the answer is D. The reason that it's not A is that ordering of questions, there is no other choices except for just planned planning should include exactly one emergency plan. They don't say or something. So there is no ordering of questions. Unintentional bias. Actually, there is an unintentional bias, but it's not the most important thing here. The unintentional bias is where they use include exactly one emergency response plan. It is not a very clear unintentional bias because, as I said, it's not like the biggest problem in these questions, because the biggest problem is where you have the deliberate bias here, where you just give people a one-sided questions. But there actually exists the unintentional bias. So there can be two answer choices for these questions. And I would warn you guys in this case, because in the assignments and in any cases in reality, there can be more than one problems with any questions that someone asks you. So do not assume that, okay, they're just going to be one problems with the questions. It's not the case. And I mean, in reality, what actually happens is that you can have a tons of problems piling up in one questions, especially when people tend to twist their questions like, don't you think that we disagree or with whatever. It usually make the thing super complicated, and it will increase the chance of that person's gonna make a mistake in making that questions. Now let's think about the second one, and this one should be quicker. How about these questions? Do you agree or disagree that planned planning should ignore the emergency response plan? And so if you look at the first phrasing, do you agree or disagree? Now it can eliminate the problem of one-sided questions or deliberate bias. But the problem now will lie in the rest. Let's see the second part. That planning should ignore the emergency response plan. And the first thing that comes to your mind, wouldn't it be, why would we ignore it? That's the thing. That's where you have the unintentional bias coming out. So this is unintentional bias. Oh, very bad handwriting. Okay, yeah. So unintentional bias is coming here. So that is the question one. Now let's go to the second questions. And again, I also give you 2 minutes. So question two asking, what are the general criteria or the steps for proper research studies? Or another way, I'm just asking you, how do we conduct a proper research study? So A, get a sample that demonstrates the population or represent the populations. B, get a large enough samples. C, determine if the study should use observations or experiments. Or D, all of the above. So let's start, 2 minutes. Let's get this. So I think this one is kind of like a easy questions. So we can go through it quickly. So what are the general step or like just how do you do a proper research study? So the answer to this one is all of the above. Now if you think about it, the first one, get a sample that demonstrate the populations. Of course, that's like the ultimate goal that we're trying to do when we take any data collections. So that is a yes. Get a large enough sample. Now, this is not, as I told you, it's not a necessary requirement, but in reality, we're talking about a proper research study. And in reality, this is how we do it. So this is also the correct answer because in reality, there obviously there's no way that you can make sure that a sample you're going to take is going to be representative of the population. So that is going to be the general step that we're going to do in the reality. But it's not the ultimate goal. It's just the general case that if we do research in real life, that is what we're going to do. And then C is also correct because when we want to study, we have to make sure the fact that you know how you're going to do the study. Say, if you're going to just observe your subjects or you're going to say randomly put them in groups and do the put some treatment or like change one of the variable between the two groups and say one is control group and one is like the test group and see if there's any difference. It's just the method you're going to do it is just you have to know it to do a research study, right? So that is question 2. Pretty easy so far, and I hope that it's clear to you guys to understand it. If you don't understand anytime, please feel free to send me an email. I'll put my email like just put it here. chgt5011 at psu.edu. So if you have any questions anytime, send me an email and also CC Professor Ellie to make sure that we help you to get on the same page with us. Now, let's go to the third questions. Which of the following characteristic would be measured as a discrete variable? The amount of fluid in liters, whether you drink coffee in the morning, the car brand you like and drive, or how many calories you burn during exercise. So, let's start it. I'll give you, again, 2 minutes. Okay. Again, it's not a very challenging questions. So the way that we're going to look at it is, as I said, we have two main types of variables, categorical or measurements. So when you look at it, the answer that we have here is B and C are categorical variables because here it's only yes or no. It doesn't come as a numbers, so it's categorical. It's a nominal variable because it doesn't give you the order of like which one is higher in order, like high quality or low quality car. It doesn't have an order inference. On the other hand, oh no, actually similarly, the car brand that you have like Toyota or Mercedes or all of that is doesn't have a ranking order at all, and it's also categorical variable. Now we're only left with A and D. So A, when I said the amount of fluid, as again, it's a continuous flow. You cannot stop the flow, just say like, okay, I mean, technically you can stop the flow, but you cannot just drink in chunks. It's a continuous flowing. It's pretty kind of like a physical phenomenon that you can actually see that it just have a continuous flow and every single molecules count. So that's it's a continuous flow. So the last thing that we have left is how many calories do you burn during exercise. Now this is kind of like the way that I phrase it might get someone to argue like, okay, you can burn say 200.1 calories. That's completely fine. But honestly, if I put it another way, say the amount of calories that you are advertised that you're gonna burn during exercise. So say the amount of calorie that people tell you you're gonna burn, say 300 or 600 calories during exercise, then that one is definitely gonna be discrete variable. Because honestly, there was no advertisement or any kind of scientific study is gonna give you a number like you're gonna burn 201.1 calories during this exercise. It just doesn't make any sense, and it doesn't follow like how like the easiest way for people to figuring out and like visualize what amount is 201.1 calories. It doesn't make that much of a difference with 200 calories. So that is what we call the example of discrete variable. Now let's go to question 4, and we only have this one and 2 more to go. So what is the ultimate goal of randomized experiment? To represent a population, to get a large amount of data from a large sample, to be able to infer about the cause and effect relations, or to allow the researchers to see which units are in each group. Now remember, the question is asking you about the ultimate goal. And so this should be very straightforward. So, but I will still give you guys some time to think about it. So I'll give you a minute and we're gonna be back for questions. Okay, so we're gonna be back. So I would say that I'm thinking in my head there would be 2 answers that you guys might be very kind of like confused about which one to choose. So first of all, we're gonna eliminate B and D. So B, to get a large amount of data. Obviously, try to get the large amount of data is one of the things, but it's not the final goal. Like, why do we actually do that experiment or that study at all? So that is not the case. And then D, to allow the researchers to see which units are in each group. So this is just a step in the experiment, but it's not the goal. It's just one of the methodology that we have to go through to conduct the experiment. So that is not the one. Between A and C, I think a lot of you, if you have listened to me so far, you're gonna think, okay, A is the answer. But you have to think about it. Why do you want it to be representative of the populations? Because we want to draw a conclusion from it. That's why we want to draw a conclusion about a population through the data of a samples. So we try to draw a big conclusion from something smaller. That's why we want the small thing to have the same characteristic as the big one. So the ultimate goal is that C, to be able to infer about the cause and effects relations. And when I say about this is where we also talk about randomized experiment. Is where we have experimental study where we actually have a solid proof of the cause and effect, the causal relations. Compared to when we just have observational study, you cannot randomly divide the subjects into groups. You cannot have much control on the subjects that you put into testing or the samples. So that's why you cannot draw a cause and effect relations if you doing observational study. But here we have a randomized experiment, which means that it's an experimental study. So pretty obvious for this. Now, let's do question 5 and one more to go. So suppose the study found that blueberry bushes receive fertilizers grows faster than those without fertilizers. Which of the following is the case? So you can read the answer choices and I'll give you 2 minutes. Okay, so we're gonna be back on to answer the questions. So first, I mean, if you look at the answer choices, there are 2 things that we have to determine from there. So the first thing is that we have to figure out if it's an experimental study and then the other one is whether there's any cause and effect relations between those 2. And so first of all, you look at a study and the study we have is that blueberry bushes receive fertilizer grows faster than those without fertilizer. So obviously there is an intervention here in the fact that the bushes, some will have fertilizer and some will be chosen to not have fertilizers. And so clearly it's an experiment. So we can immediately delete B and D where it's say that it's observational study. Obviously in reality, the choice to put the plant to give a plant fertilizers or not depending on us. So we're just gonna it's an experiment because it have human interventions into the groups. And then the next one is whether we can draw conclusions. So one of the thing about experiments is that if you have randomization specified, so if an experiment have the subjects divided by randomization, you just choose them randomly, then it allows, like, if there's enough evidence, then you can draw the conclusion that there's a cause and effect relations here. Now look at A and C. A, fertilizer could not have caused increased growth. Might be right, could have there. It was an experiment with blueberry bushes randomly assigned to each group. There might be evidence that fertilizer might increase growth of blueberry. Now, the thing here that makes C is the correct answer and not A is that you have the randomized assigned here. The answer doesn't lie in the fact that if you can prove it or not. It's more than we have the conclusion there might be evidence. So we include all the possibility or all of the choices that can answer for the questions that we have. If we ask the questions, the fertilizers change the growth of the plant, then This is the answer that give you the overall. It might be, because it might be consider the fact that we make sure that there's enough randomization. However, in A, if you want to say fertilizer could not have caused, is there evidence showing that it doesn't cause it? Actually, if you look at the statement that we have here, it actually shows the other way around. So if you want to conclude that something could not have caused, there must be evidence that those two go at least go against one another, or the fertilizer would actually kill the plant. So we don't have any evidence for the second part in A. We don't have evidence that it could not cause the growth. So that's why we say A is wrong and C is the correct one, because C include all of the possibility of your answer choices. We're not saying here that the evidence show that it's growing because of the fertilizer. We're saying there might be. That is the way that make C is correct. Now is the last questions. You discover that out of the 50 cheese plants in Victoria, by the way, Victoria is where I am right now in Australia. So just kind of like, I'm getting kind of a little bit obsessed with chemical engineering process. 32 plants out of 50 produce cheddar and 18 plants do not. It turns out that the plants producing cheddar gets about 28% higher yield per plant. What type of study is being implemented? And this one is an easy one, so I'm just gonna give you guys kind of like a minute, and we're gonna be back to answer the questions. Okay, so we're back, and now we're gonna work on this. So, discover out of the 50 cheese plants in Victoria, 32 plants produce cheddar and 18 plants do not. So the study here, when you look at it, the first sentence, discover that out of that you only have that ratio, and so the groups here is the plants that produce cheddar and the plants that do not, and there's no intervention from the researchers. So obviously the researcher wouldn't be able to make a decision if that plant is gonna produce cheddar or not and the other one wouldn't. So here it is an observational study. Give me a second to draw. Okay. So this is an observational study, and the extra questions there is what further conclusion can you draw from this case? So in this case, because it's an observational study, the only relation that we can draw have to relate it to the association, but not the cause and effect relations. So the additional conclusion that we draw from here. Now, if you want to pause the video and think about it, feel free to do that. If not, I'm just gonna give you the answer right now. Is that there is an association between producing cheddar and higher yield. But you cannot say the fact that producing cheddar will give you higher yield. That is the cause and effect relation. The only conclusion that we can draw here only has something to do with association, which is mean the only thing that we can say is that producing cheddar is associated with higher yield per plant. And so that is the end of our meeting this week. And so I hope that it helps. And if you have any questions, again, feel free to email me. My email, again, I'll put it here so that it can be, it's an hgt5011@phul.edu. And so, yeah, have a great week, and I'll see you guys next week.